Welcome again to the New York Transit Museum's virtual program on Superstorm Sandy. My name is Amy and I'm the Public Programs Manager at the museum. I'm very, very pleased to introduce Marie Fazio, our Education Coordinator. She will be talking today about the impact of Hurricane Sandy on the city's transit system 10 years ago. It's a 10-year anniversary this year. So we have enabled closed captioning for tonight's event, or for today's event, not tonight. To turn it on, go to the bottom where it says live transcript at the bottom and select show subtitle. So if you haven't been to the museum, it's definitely worth a visit. We are located in downtown Brooklyn in a decommissioned IND subway station. Right now we are open from Thursday to Sunday, 10 to 4 p.m. And you can reserve tickets on our website. So now I'm going to hand it over to Marie.
Thank you, Amy. Hello, everyone. So like Amy said, in this afternoon's digital discussion, I'm going to be talking about Superstorm Sandy and the impact it had on New York City subway. And we just passed the 10-year anniversary. So thinking about that, I'm wondering who was in the city at the time of the storm. If you want to share in the chat, if you were here or what you remember. I personally was in Washington, D.C. at the time. So we were hit by the storm, but not quite as intensely as here in New York, for reasons that I'll explain as we start the program. My room did flood a bit, though, even there in D.C. Okay. So the damage that was caused by Sandy was a huge wake-up call about the need to prepare for climate change in a city that is made up of low-lying islands. Climate change will likely bring with it rising sea levels and more frequent and severe storms. So today we'll be examining the progress that has been made in repairing the system, as well as steps that we've taken to make the system more resilient for the next time a storm does hit. So Superstorm Sandy began as a hurricane in the Caribbean and then made its way north with tropical storm force winds spanning 1,000 miles in diameter. Instead of continuing north, a combination of weather systems caused Sandy to make a sharp left turn towards New York. Sandy hit New York City on Monday night, October 29th, 2012, with 74-mile-an-hour winds. Sandy's sheer size, with winds spread over a massive area, generated an enormous surge of ocean waters. The arrival of the storm coincided almost exactly with the high tide on the Atlantic Ocean and resulted in a storm surge of 14 feet in New York Harbor. The surrounding coastline of New York Harbor channeled more and more of the incoming water into a narrower and narrower region. When a massive volume of water gets confined in that way, it has no choice but to spill out and flood the surrounding land. I remember, like I said, I was in DC, but I remember seeing on the news and in images, seawater pouring onto the city streets. Never in the city's recorded history had a storm caused so much damage, an estimated $19 billion worth, and affected so many lives, damaging infrastructure, including streets, tunnels, subway lines, destroying homes, displacing individuals, and cutting off power to millions of people. With a total of 51 square miles of New York City flooded, amounting for 17% of the city's landmass. New York City began shutting down the subway system on Sunday, the 28th of October at 5:30 p.m. And this was to prevent people coming into the city on Monday morning and then getting stranded. By 3 a.m., all of the MTA's assets were locked up, including 6,092 subway cars, 656 miles of passenger carrying track, all deserted. The only time this had happened before was in 2011 during Hurricane Irene, which was smaller in size and caused much less damage. Here you can see a very strange image of Times Square, which is normally New York City's busiest subway station. But here on the evening of October 28th, it is completely deserted. So maybe the only time you would have seen something like this. The MTA installed plywood and sandbag barriers at critical station entrances and ventilation grates, which can be seen here in this picture of the Bowling Green station entrance. In fact, NYCT used 1,200 sheets of plywood and 15,000 sandbags in preparation for Hurricane Sandy. Interestingly, the grates were a novel engineering design when the subway was first designed in the early 20th century, because the flow of air into the subway was a big concern for New Yorkers. And the grates allowed passing trains to draw fresh air into the tunnel by different air pressure as they zoom past. But now during the storm, they become massive sieves through which the stormwater and seawater, depending on the location, can pour into the system during a storm. So subway cars and buses were moved to higher ground, major bridges and tunnels were closed, and Mayor Bloomberg ordered Zone A evacuated. Not everyone did evacuate, but 375,000 people were evacuated from Lower Manhattan. So New York City is located at the meeting of the Hudson River and the Atlantic Ocean on one of the world's largest natural harbors. This harbor is what enabled the city to become the major trading center and, become the city that we are today. But it also is what makes the city vulnerable. As can be seen on this elevation map, the land surrounding the harbor is extremely low-lying. So here in this key, you can see that the darker green is the lowest elevation, and we see a lot of New York City is that green color, especially here near the harbor. Large areas of Lower Manhattan are reclaimed land, swampland that was part of the ocean and made into property over the centuries. As you can see in the map on the right, the borders of Manhattan Island were much further back in 1650. By the 1980s, it had expanded 1,000 feet. This began with the Dutch, but continued throughout New York City's history. The most dramatic reclamation took place in the 20th century. In the 1930s, Manhattan was expanded to the east with the construction of the FDR Drive, which runs 9.5 miles from Lower Manhattan to the Triborough Bridge. And this was made up a combination of landfill and pile-supported platforms. And in the 1970s, with the creation of the Battery Park City along the Hudson River, with landfill excavated from the construction of the original World Trade Center. So Sandy's storm surge inundated these areas and took the city's coastline back 400 years. It is the shape of this coastline that magnified the storm surge and made New York City even more vulnerable. The entrance to the harbor acted like a funnel. Waves slammed up against the South Queens and Staten Island and into the harbor. Then you have the second opening through the East River that connects to the Long Island Sound. Long Island Sound is shaped like a funnel, and as winds push the water towards Western Long Island, then they head up through the East River and into New York Harbor. As a result of the miles of low-lying coastline, you have the creation of the hurricane zones. And in the case of Superstorm Sandy, Zone A had been ordered to evacuate. So Zone A on this map is the orange. The storm surge generated by Sandy had a massive impact on the transportation system in New York City, particularly on the elements located underground and those close to the shoreline. The New York City transit infrastructure sustained more than $4.5 billion in damage. The worst of Sandy's wrath was felt in Lower Manhattan, on Staten Island, in the Rockaways, and in Brooklyn at the Coney Island rail yards and maintenance facilities. Salt water from the storm surge poured into entrances, sidewalk grates, even manholes, and subway tunnels and subway stations and rail yards were flooded. Exacerbating flooding was the loss of electrical power below 34th Street, which made it difficult to pump water out immediately. This increased the damage from Sandy as mechanical, electrical equipment was soaked in corrosive salt water for an extended period of time. So the first step in restoring New York's subway system was, of course, pumping out all this water. So you can see in the image here is a pump train pumping water out of the Cranberry Street Tunnel on November 2nd, so a few days after the storm. After the MTA had removed all this water, an even more daunting task was inspecting, cleaning, and repairing all of the electrical components that are crucial to the safety of the trains. Critical signal systems that are used to space the trains out safely had to be evaluated. The segment of wiring that detects trains along every part of the track, connections to the signals, and connections to control rooms all needed to be cleaned of salt water, which can cause corrosion, and then they all needed to be tested for damage. 1 week after Sandy, many subway lines had been fully or partially restored, but some elements of the system remained closed for much longer. The subway opened with limited service 2 days after the storm and was running at 80% capacity within 5 days. Infrastructure that needed repairs were staggering over several years, starting in 2013. I see a question, where was the water pumped to? The pump trains pumped the water up to the street and into the sewers. So here in this image, we see the South Ferry station flooded, which of course, many of you probably know is one of the stations that did have a lot more of that extensive damage and longer closure. And we'll get into talking about the South Ferry station in just a moment. All right, so as I said, the impact hit throughout the system, but there were places where it was more extensive. And in today's presentation, I'll be focusing on what occurred at the South Ferry station, the Canarsie tunnel, and finally the Coney Island yard. So the South Ferry station that was damaged and needed to be completely rebuilt after Superstorm Sandy was actually a new station that had only just opened in 2009. It had been built to replace the original South Ferry station, which had been in operation at that point for 104 years. So here is an image of the new station that opened in March 2009. And this project was paid for with money supplied by the federal government for the rebuilding of Lower Manhattan following the September 11th, 2001 attacks. The terminal replaced the single track 5-car loop with a 2-track 10-car stub terminal with a better connection to the Staten Island Ferry and a connection to with the 1 train and the R and W train. So as you can see in this image, that it connects the South Ferry 1 station with the Whitehall Street RW station. The original station was located at this site. So prior to, even the old South Ferry station was the South Ferry Elevated Station, which opened in 1877 and was the terminal for the 2nd, 3rd, 6th, and 9th Avenue lines. This was followed by the original subway station, which we can see under construction here in 1904, which then opened in 1905 when the tracks were extended from City Hall Station to South Ferry and becoming the new southern terminus. So this photo shows that original construction in 1904, and the station was built as a loop so that the trains could head back uptown. And it was originally built for a 5-car train to fit around that curve. Also, as many of you know, if you've been to any of our City Hall talks, that this loop could be a problem once center doors were added to train cars. So originally, the train cars had doors only on the very ends, which meant even with that curve, the doors were fairly close to the platform. But once doors are moved in from the side into the center, or even just away from the very edge, there's a pretty large gap between the train and the platform. And yes, someone in the comments mentioning the screech going around the loop, it does make quite a loud noise. So here in this diagram, we could see the problem that this station caused when trains were extended to 5 cars. So when station platforms, a lot of station platforms were lengthened in the 1940s to accommodate 10-car trains, but at South Ferry, this was not possible because of that curve. So to exit the train at South Ferry, passengers had to move to the first 5 cars to exit. So the conductor would announce to passengers at previous stops, to exit the train at South Ferry, you must be in the first 5 cars of the train in front of the conductor's position. So like the City Hall station, it could not be extended, but unlike City Hall, it was too vital of a station to close down, as there were not alternative stations nearby to give commuters that connection to South Ferry, the Staten Island Ferry, that they needed. So here in this diagram, we can see the green cars are on the platform, but these red cars are in the tunnel without access to the platform. So of course, conductors cannot open those doors. And so passengers must be in the front. There's also only one exit, and it was not an ADA accessible exit. So here we can see that they needed these platform extenders to reach those center doors and not have that dangerous gap in the platform. The new South Ferry Terminus Station opened in March 2009 at the cost of over $530 million and corrected many of the operating deficiencies of the old one. So you can see the locations of the stations in this diagram. So here on the top, we can see the loop, which is the original station. And then in this darker red orange color, that's the new station. And the new station was a true terminus with tracks ending on either side of an island platform. And it was built beneath the original station. It was opened as a complex, providing a connection between the Broadway 7th Avenue 1 train and the Broadway lines NR and W trains originally built by the BMT. So the new station also had a better connection to the Staten Island Ferry, and it reduced the noise. As you were mentioning, we don't have that very loud screech around the curve with this new station. So here are some pictures of that station, and it is a full-length platform that accommodates 10-car trains, and it greatly reduced customer travel time. So previously, like we said, conductors would have to wait to open the doors while they waited for the platform extenders to open, in turn making the passengers wait to exit. The new station can handle 2 10-car trains on parallel tracks versus the half of a train on the old station. The new station with parallel tracks allowed more frequent service on the 1 line. Headways were decreased from 4 minutes to 2.5 minutes, 24 trains per hour instead of the previous 10 along the 1 line up to Van Cortlandt Park. Oops, sorry. Okay. The new station had thousands of white tiles, 2 sets of tracks, 2 elevators, 7 escalators, and 96 security cameras. So this station was fully accessible with additional ADA entrances added. And here in this image, we can see one of those escalators, some of the artwork that was added. So despite the efforts of the MTA in trying to barricade the station entrances and ventilation grates before the storm, when the storm surge hit, water poured down the stairs and filled the station from the track level to the mezzanine. In total, Sandy brought 15 million gallons of corrosive salt water into the South Ferry complex, carrying with it thousands of pounds of debris. South Ferry is a terminal station, so the tracks end at the wall and there was nowhere for the water to go, which means it just filled up the whole station. And this was exacerbated by the slight slope towards the bumper block at the end of the station. This water could not be pumped out for a week. As I mentioned before, there was no power below 34th Street, and manpower were required to operate the pump stations. So here in this image, we can see up on the mezzanine by the turnstiles, the water all the way up there, as well as, chunks of tile and, who knows what else that was carried in. And then in this picture on the right, we see an escalator, which, I'm assuming is even more damage than we can tell by the photo. So when the water was finally pumped out, and drained, the extent of the problem became clear, and the station was inoperable indefinitely. Damage had been sustained by both the structural elements of the station and the electrical system. Tiles had been ripped off the walls, plaster and paint hung from ceilings, turnstiles and other MetroCard equipment suffered extensive damage, escalators were damaged, and other electrical equipment was destroyed. Equipment was not only submerged, but evidence of the corrosion from the salt water was apparent. Signals, which are used to keep the trains a safe distance apart, were destroyed, along with switches, which connect the station's two tracks to each other so that trains can enter and leave from either side of the center platform. Crew removed hundreds of relays, which are the electromagnetic devices that let the system know where the trains are in the 1,000-foot sections. In 1,000-foot sections of track. They tried to clean these, but they had been damaged by the corrosive salt water and instead needed to be replaced. So this station needed to be completely reconstructed at the cost of $343.9 million. And so what's old is new again. 5 months after Superstorm Sandy, the MTA reopened the original South Ferry loop station. While there had been some damage to this station as well, one of the biggest challenges in getting it up and running again was reinstalling those mechanical gap fillers that we saw earlier, because these had been removed from the station. Additionally, a connection between this ferry and the South Ferry Whitehall RW station needed to be added. The station had been decommissioned when the new one opened, meaning this was the first instance of a decommissioned station ever returning to passenger use. So here are some images, again, of that reopened station. You can see the original tile work from 1904 in this image on the left. And then on the right, you can see some of those signs for the conductor, telling the conductor, reminding them, make sure you only open the front section and that they wait for the gap fillers. So the MTA set to work on rebuilding the South Ferry station and protecting it and other vulnerable stations from future storms. So they came up with a few new solutions to prevent water besides just the plywood and the sandbags that had been installed before Sandy. One of them you can see here on the right are stop logs, which are a system of interlocking logs at the entrances of some stations. The 80-pound aluminum logs are stacked at subway entrances that are prone to flooding. They take about an hour to install because things are done manually, as the MTA cannot rely on electricity during what could potentially have a blackout. They also installed subway ventilation grates, which, they also covered subway ventilation grates, which presented a huge issue for flooding caused by the storm surge. So the MTA installed mechanical closure devices and metal hatch doors below the street. They are trap doors that can be closed in a matter of seconds with no electricity needed. There's also flex gates, which are tarps that can be rolled out by individuals. Finally, there are marine doors, which are heavy-duty marine type doors at subway station entrances. And these doors weigh about 3,000 pounds, and they're closed using a pump that is about the size of a bicycle pump. A rubber gasket around the door is inflated and it seals off the entrance. The newly rebuilt and more resilient South Ferry station is pictured here in June 2017. So that's here on the right of the screen. I mentioned earlier the low elevation of New York City and the land reclamation that had taken place on Manhattan Island over time. So here I wanted to briefly mention the artwork on the station walls at South Ferry. The artwork is titled See It Split, See It Change, and was created by artists Doug and Mike Starn as a multi-part site-specific installation that encompasses the entire interior of the new South Ferry Terminal Concourse. As passengers enter the station through the turnstiles, they are faced with an expansive view of a 20-foot wide floor-to-ceiling map of the island of Manhattan, which has been pieced together in an intricate marble mosaic extending down the stairs to the platform. The island's original topography emerges behind a more familiar diagram of the modern city, depicting in relief on top. So you can immediately see all of the land reclamation that had taken place around Manhattan Island. All right, so now we'll move on to looking at the Canarsie Tunnel part of the L line. The Canarsie line, the L train, runs between Rockaway Parkway in Canarsie and 8th Avenue in Manhattan. Named after its terminus in the Canarsie neighborhood of Brooklyn, it is used by the L service, which is shown in the color gray on the New York City subway map. It is also sometimes referred to as the Eastern District line, which refers to Williamsburg, which is known as Brooklyn's Eastern District. The Canarsie line was first a steam railroad, then a BRT elevated line, and then extended to Manhattan via subway by the BMT as part of the dual contracts. The subway part of the line was initially constructed running from 14th Street and 6th Avenue in Manhattan through Williamsburg to Montrose Avenue and Bushwick Avenue in Brooklyn in the 1920s by the BMT. So these images on the screen are from that original construction of that L line. We can see here being constructed under 14th Street, and a survey photo taken by Granville Pullis. As you can see, the excavating underway for the subway with trucks ready to carry off the road and earth that had been excavated. The tunnel under the East River, constructed in 1924, consists of 2 tubes made of cast iron and lined with concrete, which travel under the East River between Manhattan and Brooklyn. In 1928, it was extended east to Broadway Junction, and in 1931, it was extended west 2 blocks to 8th Avenue in Manhattan, connecting to the I&D 8th Avenue line. The number of people using the L has grown drastically in recent decades, with ridership tripling since the 1990s. During peak times, 40 trains an hour pass through the Canarsie Tunnel. On average, each weekday, 400,000 riders were using the L train, and 225,000 of these riders used the Canarsie Tunnel between Brooklyn and Manhattan. A feature of the Canarsie line is that it is one of 2 NYC subway lines that do not share trackage with other services. And because of this, it was chosen to be the first line equipped with communications-based train controls, CBTC. CBTC was rolled out across the whole L line by 2011. CBTC uses radio waves to pinpoint exactly where the trains are, which is a big improvement on the block signaling system, where we can only detect where the train is within a block, within, a set piece of the track, rather than its exact location on the track. And this meant that only one train could be allowed into a block, whereas knowing exactly where each train is makes it possible to run the trains closer together and therefore increase capacity and better serve the growing part of the city that the L line was serving. Unfortunately, it was this new signal system that was severely damaged during Superstorm Sandy. During Superstorm Sandy, the Canarsie Tunnel was filled with 7 million gallons of corrosive salt water, which flooded in from the East River. This photo shows activity on Monday, November 5th, as MTA employees are using a pump train to pump seawater out of the L train's tunnel under the East River. Salt water damaged the tube structure, the tracks and ties, and signals and other electrical equipment. The worst damage was to the duct bank, which are concrete tunnels located in the bench wall. So the bench wall is, this kind of spot here where you could walk. These provide a protected pathway from the miles of cables and circuits necessary for communications, power, and the safety of trains. Salt water flooded into the duct banks and silt dried out inside of the structure, hardening like cement and destabilizing the duct bank from within. It was originally thought that the L train would have to be closed completely in order to undertake the repairs. People, started to move away from their apartments near the L line. It's very serious thought that the whole thing would need to be shut down. But following advice from Cornell and Columbia engineers working with the MTA, it was announced by the governor in January 2019 that the shutdown would not be a full-time closure, but rather a disruption to service on nights and weekends. In April 2019, the MTA began a 15-month project on repairing the Canarsie tunnel, balancing construction and service while working to repair the line. Work was limited to nights and weekends when service on the line was reduced to every 20 minutes. So here on our screen, we can see, a service advisory letting you know that the L is only running every 20 minutes between Manhattan and Brooklyn. Instead of replacing cables inside the bench wall, so that would be over here on each side where my mouse is moving. It was decided that a racking system would be installed to suspend new cables on the side of the tunnels. And this included cables for communications, pump power and control, signal cables, and lighting. So that instead here, they were installed on the wall where my mouse is moving now. The cables in the bench wall kept the system running while the work was being done to replace the new cables on the racks above. The racking system has been used in construction of modern tunnels, but this was the first time that it was used to repair an existing tunnel. The new cable racking system means that the cables are accessible and can easily be added and/or upgraded with latest technology as needed in the future. Instead of replacing 32,000 feet of bench wall, where weakened but structurally stable, it was allowed to remain with and was fortified with fiber reinforced polymer wrap, which is a technology that has been used to hold together pillars of bridges damaged in earthquakes. Where it did need to be removed, it was replaced with a walkway. Rebuilding of 12,610 feet of track was also needed, which includes continuous welded track, which means a smoother ride for passengers, as well as less friction on the track, which lessens the need for maintenance and allows trains to run more efficiently. Additionally, upgrading of the pumps and drainage system in the tunnel, as well as putting storm and flooding resiliency measures into place. So with pump capacity was increased and more drainage pipes. So basically allowing it to withstand more water coming into the system than it previously had been able to. To monitor the Canarsie tunnel's interior, smart fiber optic sensor cables were installed along the bench wall to detect small shifts or cracks. There was also improved lighting and construction of 3 new power substations, upgrades to stations along the line with wider staircases, more turnstiles, new escalators and elevators, making many of the stations ADA compliant. Here you can see images of the work in progress, and the work was finished in April 2020. All right, so for the final part of our talk, we will look at the Coney Island Yard. The Coney Island Yard is one of 24 rail yards operated by the New York City Transit Authority. The Coney Island complex was built in 1926 on former marshland that, along with Coney Island Creek, used to separate Coney Island from the main body of Brooklyn. This photo from the Transit Museum archives shows the yard in 1928. This facility supports a large car maintenance, inspection, and overhaul program, as well as being the largest car storage facility in the system. The Coney Island complex is the largest rapid transit yard in the state of New York and one of the largest in North America. Located in Brooklyn, it covers 74 acres and operates 24/7. The yard stores and services 881 subway cars and deploys 71 trains into daily service across 6 lines. While regular maintenance is performed by 13 different maintenance shops throughout the system, heavy maintenance or overhauls of the 6,500 cars in the system are done at the 207th Street Yard for the A Division and the Coney Island Overhaul Shop, which serves the B Division. So this is a focus on preventative maintenance. This system is known as the Scheduled Maintenance System, or the SMSing of the cars. Every car is rebuilt every 6 years. These are the sort of repairs that are out of the scope of the 13 maintenance shops. With this system in place at any time, each subway car is at most 6 years from its latest rebuild. So the yard is in a flood zone and vulnerable to water flowing from nearby Coney Island Creek. During Superstorm Sandy, the storm surge caused the creek to flood and inundate the yard complex with over 27 million gallons of salt water and debris. While subway cars had been moved to higher ground, the salt water and debris quickly inundated the tracks, switches, motors, and signal equipment. The storm left the track switching operation at the maintenance and storage facility unable to be controlled remotely. Individual switches had to be hand thrown because the capability of operating from the tower was completely wiped out. Changing switch positions is necessary on the maintenance side of the house in order to send trains in and out of the barn. Water was pumped out, switches and signals were eventually repaired or replaced, and they got trains running again after the storm. Since Sandy, the MTA has been working to protect the yard and all that it holds against severe weather with an ongoing resiliency project. So here in this image, you can see that they've installed a flood wall around the yard. This wall is 12,000 feet long, 14 feet high, and 30 feet below the ground. Replacing existing switches with this new submersible switches in 2 locations. So they made switches that were waterproof, could be submerged in water. They improved the drainage system beneath the yard, and they have installed debris shields on the bridge that crosses Coney Island Creek. On the 7th anniversary of Sandy in 2019, the MTA also announced it had reached a resiliency milestone with construction of a state-of-the-art elevated cable bridge, 4,280 foot long bridge to carry power, feeder, and communication cables across the yard. So raising a lot of that equipment up into the bridge rather than having it run along the ground, of course, means that it is safer from flooding. So this also, it makes them easier to maintain in addition to protecting them from weather. The bulk of the Coney Island Yard resiliency work is slated to be completed by the end of this year. The threat of climate change to the MTA remains with so much waterfront and flood-prone infrastructure above and below the ground. This has been recognized by the MTA, acknowledging that as the weather becomes more extreme, it is going to be a continuing effort into the future. Since Sandy, the MTA has focused on preventative measures to protect against another storm, and billions has been spent to restore and fortify infrastructure and to incorporate resiliency into every project. This photo shows MTA bridges and tunnels taking advantage of reduced traffic volumes in May 2020 to ready its 25-ton floodgates on the Hugh L. Carey Tunnel, formerly the Brooklyn Battery Tunnel. Work on the Rutgers Tunnel, which carries the F train under the East River, the final subway tunnel to be repaired, was completed in the fall of 2021. Rutgers Tunnel was flooded with 1.5 million gallons of salt water. Montague was the worst rail tunnel hit with 27 million gallons of water. The MTA recognizes that it is not a matter of if, but when another storm will hit. So if the subway is prepared for this next huge storm, we'll have to wait and see, but it certainly will be more well prepared than it was for the last storm. So thank you everyone for joining me today. Our museum is open in downtown Brooklyn. We would love to see you in person. We're open Thursday through Sunday from 10 to 4. You can get your tickets in advance on our website at nytransitmuseum.org/visit. And if you're excited about our programs, you can consider donating or becoming a member at nytransitmuseum.org/join. Thank you so much, everyone. I'm going to pass it back to Amy to wrap us up today.
Thank you, Marie. That was so interesting. I think you covered everything. I just want to let everyone know our next virtual event is on Thursday next week, November 10th, with Polly, our content manager. So I'll put a link into the chat. Hope you can join us. It's going to be on Elizabeth Jennings Graham, who's a really kind of powerful figure in transit history, and I think it's going to be great. So please come and join us. Thanks again, and have a great weekend, everyone.
Bye, everyone. Thank you for coming. Thank you for your kind words in the chat.